So that's a 2-bit addition. 2-bit addition is sometimes called half addition. Okay, because there's a full addition. Okay. So 0 plus 0 equals 0 carry 0. 1 plus 0 is 1 carry 0. 0 plus 1 is 1 carry 0. Same thing. No? 1 plus 1 is 0 carry 1. So here's the circuit that computes half adder. No? The sum is done using an XOR. Okay, XOR. If you look at that, no, so it will become. It should be an. Okay. The sum is 1. No, when exclusively there's only one of ones. But when there are two ones, it will be 0. So it cannot be an OR, but it's an XOR. Okay, and the carry is ANDed. No, diba? Okay, because an AND gate will get the carry. Okay, any questions? Sometimes, no, in a circuit, by the way, in Cedar logic, we have a half adder. Okay, that is written like this. No, I'll show you that later. Okay, that's called a half adder. Okay, I'll show you the Cedar logic white box. So, which means that in a white box, in a circuit, we can just use the white box, but we assume that the inside of the white box is like this. It allows us to create a much simpler circuit. Okay, there's a facility like that in Cedar logic. Any questions? 3-bit addition. 3-bit addition is also called sometimes as full addition or full adders. No? So take note that the sum is using 2 XORs. No, an XOR of no, because 1 plus 0 0 plus 1. Let's look at the sum. No, there's one here, so 1. Sum is 1. There's 1 1 here, so the sum is 1. There are 2 ones. Okay, there are 2 1, so the sum is 0. Here there is 1 1, so the sum is 1. There are 2 1, so the sum is 0. There are 2 1s, the sum is 0. There are 3 1s, the sum is 1. So an XOR gate, a 3-bit XOR gate is actually an add parity generator. Diba? We discussed add parity generation. So if it's add parity, the sum is 1. So let's take note, 1. 1 is odd. There's another 1. 1 is odd. Now 0 is even, so therefore it's 0. No? There are 2 1s, even, so 0. There's 1 1, that's odd. There are 2 1s, that's even. There are 2 1s, that's even, so 0. There are 3 1s, that's even. That's odd, so there's 1. Okay. Now, if you look at the sum, okay, there are 3 min terms, no, not A, B, C, A not B, C, A, B not C, at saka A, B, C. Now you can simplify this using K-mapping. Do you follow? Okay, you K-map this. I don't have to do that myself anymore, no? Basta i-K-map mo ito, you will have a simpler equivalent of the carry, which is AB plus AC plus BC. Okay, take note that there are only 3 left instead of 4 because we did a K-mapping. Okay, i-K-map mo itong mga min terms na to, and then you will have carry as AB plus AC plus BC. So here's the Cedar logic. Now, why is there an like this? Because we don't have a 3-bit XOR gate. Okay, if you have a 3-bit XOR gate, you can use the 3-bit XOR gate. Now, before. That was before. So here's the white box, a representation of the full adder. Okay. Okay. So how can we create a nibble adder? Okay. For example, how do we add 2 words, 2 nibbles together, A and B, where A is A0, A1, A2, A3, and B is B0, B1, B2, B3. What we'll do is we add A0 with B0, and then we send the carry to A1 and B1, so that we'll have S1. And the carry we send to A2 and B2, so we'll have S2. And the carry we'll have to A3 and B3, so we'll have S3. And C4, which is the last carry, which will be an indicator. Now, if it's 1, it's a positive number. If it's 0, it's a negative number. Okay, do you follow? I'm sorry, no. So if you have 4 white boxes, no, the first is a half adder because it only adds 2 bits, and then we will send the second is a full adder because it will add A1, B1, and the carry of the first, no, half adder. The third will be a full adder because it will have A2 plus B2 plus C2, which is the carry of the second full adder, and so on and so forth. Do you follow? Do you follow? Okay. So that's a symbol of a register adder. Register na ito ngayon, no? M-bit binary adder. Okay. Now, if you have a 4-bit adder, you can have an 8-bit adder by putting 2 4-bit adders side by side, connecting the input to the output of the first as the input to the second. Do you follow? No, you can imagine that, no? Okay. How do we do binary subtraction? We convert the negative number into 2's complement. Diba? 1's complement of a number is the binary number. The 2's complement is 1's complement plus 1. Okay? How do we convert a 1's complement? Now we can use an inverter and we can also use an XOR gate. We'll try to find out later, no? How that one is done. It's like this, no? Okay? So this is the circuit that we are using here is a plain adder. Okay? This circuit is a modified adder that can do a subtraction. It has an additional input sub. This sub will convert B into its 2's complement. Let's find out why, no? The XOR gate converts to 1's complement if sub is 1. Do you follow? If sub is 0, B will retain the same because anything XOR with 0 is itself, right? Because an XOR is like an OR gate. If there are two, if the other bit is a 0. Do you follow? If the sub bit is a 0, the XOR gate is like an OR gate. So therefore, B0 XOR sub will become B0. B1 XOR sub becomes B1 if sub is 0. Do you follow? Now, if sub is high, this will be converted. B0 will be converted into 1's complement. Do you follow? Meron ba tayong ano dito? Okay. Okay. For example, 1 XOR 1. 1 XOR 1 is 0, right? Because it's even. But 0 XOR 1, 0 XOR 1 is 1 because it's odd. Okay, so it will be converted into 1's complement. And then the 1's complement will be added together. And you may ask, how is the 2's complement done? The sub is also entered as the carry. This time, the first bit is a full adder. It's not a half adder because the first carry, which is 0, is used to complete the 2's complement. This will add an additional 1 if sub is 1. If sub is 0, it just adds a 0 and does not do anything to the result. Okay? Do you follow? So there are already integrated circuits that can do addition and subtraction, like the 74LS83. Now in the past, before the pandemic, we used to create adders and subtractors on board, no, using 74LS83. Okay, so this can add four bits, 0, A and B. Okay, do you follow? Okay, so saan ba nakalagay, no? Sub. So this is the sum, no? S gives you the sum. Okay, S1, S2, this is the output. But where is the subtraction, ano? Okay, hindi natin na okay, but have I shown you the circuit to do subtraction? Let's call Cedar logic. Okay, now if you look at Cedar logic, no, let me open my other file before. Okay, ito yung mga decoders, no? You will have This is a full adder, no? We can actually use an XOR gate here. This is a half adder. Now, if you look at Sidor logic, no, in MOOCs and decoder, you have a. Do we have an adder here? Where do we get the adder? Decoder. Let me check, no? Kasi it's in my flip-flops na tayo, no? By the way, no? We have flip-flops here. We can create registers. So maybe we can. We also have registers, no? So we have okay, registers and counters. 8-bit count. There's a plain register. There's a 8-bit counting register, and there's a 12-bit counting register, which means that it's a counter. Okay. Flip-flops. Yeah, we have a full adder here, no? This is a white box full adder. Okay, so that if you look at this page, this is the 4-bit addition. Okay, do you follow? Do you get my point? I'll upload this. I think this is already in our already uploaded in our in our web page. Okay, the common logic circuits. For example, if you are going to add, okay, if you are just going to add, subtract is low. Okay, so for example, we are going to add 5 plus 2. Okay, 5 is what? 1, 0, 1. Okay, and 2 is what? 1, 0. Okay, so 5 plus 2 is 1, 1, 1. 1, 1, 1 is 7. Do you follow? And C4 here is red, so it's positive. Okay. However, if you do a subtract, take note here, no? This becomes a red. This becomes a red. Take note that this is retained as it is because sub is 0. It's being XORed as with 0. This is retained as itself, no? Now, if you do a subtract, we'll click this, no? So we'll have 1, 1, which is 3. So this is actually 5 minus 2 equals 3, and the answer is positive. Do you follow? If you take a look at that, no, we know that B0, which is black, is converted into a red. Okay, because it's XORed with a 1. So it's converted into 1's complement. Okay? If you look at B1, which is a red, is converted into a black. It's converted into 1's complement. B2, which is a black, it's converted into a red to 1's complement. The same as B3 from black to red. Do you follow? So the sub here, the XOR gate, will convert into 1's complement is if the subtraction is high. And the additional carry is added to the first bit so that we will have a sum. Okay? Do you follow? Let's try 2 minus 5, okay? 2 is 1, 0. So this is 1, 0, okay? Let's remove this, no? And 5 is 1, 0, 1, okay? So that's still 5 plus 2 plus 5. When we do a subtract, take note, no? This is 1, 1, 0, 1, okay? And C4 is black, so it's negative. What is 1, 1, 0, 1? This is the 2's complement of negative of 3. Because 3 is 0, 1, 1. Okay? The 1's complement is 1, 1, 0, 0 plus 1. This is 1, 1, 0, 1. We know that this is in 2's complement because C4 is black. Do you follow? Okay? Do you follow? Take note here, no, that we are using a white box at this full adder. No? White box ng full adders because Cedar logic gives us white box full adders, no? Okay, do you follow? We will not have experiments on registers and counters anymore, but we have flip-flops, examples of flip-flops, no? We have D flip-flops, we have negative D flip-flops, no? We have JK and we have JK. We don't have an SR flip-flop, okay? But okay. Pwede rin pala ito, set and reset, no? A JK flip-flop can be used as a substitute for an SR. Okay, anyway, in itself, no, SR flip-flops are not used, no. They're only used to, no, to demonstrate the use of uh, JK flip-flops. Okay, any questions so far? No? So that is about ALUs, no, arithmetic logic units. Let's say this. Do we have exercises? We will review Quine-McCloskey again. No? I'll give you a more specific example. Circuits for 4-4, no? 4-14 and 4-3.9 and 4-40. What page is this? This is in page 110. Okay. Here's an exercise. Implement a full subtractor using a minimum number of gates. I-skip na natin ito. That's already the minimum number of gates. What's this? I'll improvise this, no? Ay mali dito, no? Kasi masyadong ano yung pagka ano. Okay. Petrix will discuss this next week. I'll prepare for a more elaborate ano. So flip-flops tayo. The problems of flip-flops, no? Page 11 338 and 340. Okay. We'll just discuss this anyway, no? You can answer this, but this will not be ano. Exercise lang, no? Flip-flops. At meron pa tayong ano, we still have, by the way, exercises on time, propagation delay, setup time, and hold time. Let's do this in November. Or 5 na lang. We have exercises on flip-flops. And then setup time and hold time. Okay. Okay. Page 388 and 340. Bakit nagkaganito ito, no? Text file, Excel ito, no? By the way, no? Let us check. No? Page 388. Count. We close this first. Page 388. 388 ba o 338? 338 pala. So, 338. Eleven to 13. 11-13. 11 to 13. 15. Page 338. Okay. Chapter 11 ito eh. No? 13 to 15. Okay. 18 and then 22. Let's go to problem 13. Complete the timing diagram for the SR latch. Okay? Assuming Q begins at 1. No? So, kulang tayo ng Q dito. How can we copy this? Let's do this in Excel na lang, no? I'm sorry about that. It's not the Excel that I'd like to have. Any other newcomer? Meron pa bang newcomer? Okay, close ko itong aking ano, no? Villar Luares here, so yeah. Tabon, Reliano, Tion, Jesus. Okay. Jesus, wala. Duguran. Okay. Espera, Cardinal. Okay. So I have to close this, okay? Let's just copy the 11-13. Hindi pala yun, no? Ito pala. A and B latch operates. If A and B. Let's change this to 11-11 na lang. Mali ito, no? 11-11. It's an irrelevant problem, no? Mali yung, let's just change this, 11-11. Mali yung ating, no? Huwag na lang yung 13, no? 11-11. Kasi irrelevant itong ano, 11-12. Maganda itong ano, no? 11-7. 11-7, 11-8. Mas relevant ito, no? Mali yung aking ano. 11-7, 11-8, 11-9. 11-7, 8-9. Okay? Let's edit that. Optional na lang ito, no? Seven, 8. 11-7 to 9. I have to change this now because maybe I'm using a different edition before, no? 11-7. 11. Which page? Am I on the correct page? Check. No? 337. Okay. 337. 337. But 11:22 and 11:22. 21. 21 na lang. 22. 21, 22. Huwag na lang yung 21 kasi madali lang naman yun. 22 to 25, okay? On page 344, okay. This is already on page 2. So mali nga itong ano, no? Mali nga itong, this might be an older edition that I'm using, okay? So I'm sorry about that, no? So dito tayo sa 11-7. Complete the following timing diagram. So let's make a clock. Mabuti sana isulat ko na lang, no? But anyway, we'll do that in Excel, no? This is 11-7. Okay. First, we'll format this like that. And this one we will format with left, format with top, then we'll format with right. Where's the right? Can we just copy this? Ito na, di ba? This is our clock. This will be our J. Lagyan natin ng space, no? J. This will be our K. This will be our Q. This will be our answer. Ilan ito? 1, 2, 3, 4, 5, 6. So we just have to copy one more and then repeat. Okay. Pwede isang Excel na lang ito i-pass in case you would like to pass, okay? So ito yung ating clock. Can you see that? Can we do a border, no? Mali ako, no? I should have used a thick. Klaruhin ko muna, no? Let me do this. And let me just use a thick border. No borders. Okay. Thick bottom border. Then we'll have a thick right. Thick left. Wala tayong thick left. Ito na lang. Okay. Wala tayong thick left. Oh. Wala natin ganyan. Then let's remove the no? Bottom border. How do you remove the bottom? Wala, no? Anyway, wala tayong thick left. Thick. Wala tayong thick left. Sige na lang. bottom. No border left. Sayang, nawala pala pa. No, no border. Put the bottom border. Bakit na ano? We save this. Let's do that later, no? So anyway, take bottom border. Bottom border na lang. I'm sorry, I have to do that again. Bakit nag-taken? Anyway, tayo mo left or border, top border, then right border. Okay, anyway, nag-taken siya, so that's what we'd like to do. And then we'll have one more here, one more bottom border. Is that correct? Okay. I'll save this as what exercise is this? 11, no? Flip-flop. Flip-flops. Okay, you follow? That's what we have, and then we'll have this in the middle of the first. Paano natin yan gagawin? By the way, we'll have to draw a line now. In which case we have to draw a line. Shape. Where do we get the shape? Kasi nasa dulo. Oh. Shapes. We'll have to draw a line. Where's our line, ano? Thickness. Dito yung lines, no? I'm not familiar with the new, ano? Line. We'll draw it in until the middle of the first. Okay. Then, nandito na pala. Another line. Like that. And then we insert another line. It will be until the middle of the third. Okay, and then we'll have to draw a vertical, a horizontal, a line again. Next time I'm going to do this offline, okay? just copy this. Move it a little. Okay. Then we'll have 1, 2, 3, 4. In the middle of the fourth. 1, 2, 3, 4. One, two, three, four. And on the fifth. Okay. Okay, and then we'll copy just copy this. Diba na? Oh, may tao to. Asa si Day? Day, nag-iisag ano Day? Kontak Day. Papuli na siya Day. Nag-iisag ano sa gate, tapos nag-ano sa klase. Let's copy this. You follow? Bakit? This is a block. Color will. Okay. Now, we can just copy this, the first, because we will have to extend. No? This is our K, and our K is extended up to this. Okay, you follow? This is our K, and then we'll copy this. There may be another way to do this easily, no? Okay, let's save this. J and K and Q. Let's okay. Initially, no, the clock okay, the clock is positive, no. We assume because it's not given to be negative, no. Okay. Eleven dash 28. 11 dash 28. Where's 11 dash 28? Let's look up 11 dash 28. Figure 11 dash 28. So it's a positive. This is 11 dash 28, no? Okay. So it's a positive clock. Do you follow? Figure 11 dash 28. So it's a positive clock. Okay. So we'll look at the rising edges. Okay. Do you follow? So when it's 0, 0, what will happen to Q if it's 0, 0? No change. And then we are given that Q is initially in 11 to 7. We are given that Q is initially low. So therefore, at this point there will be no change. No, we'll just copy this. There will be no change up to this point. No. Now, what will happen at this? We have a positive clock, but we are looking at the positive edge, so nothing will happen. And then the next significant will occur on the next positive edge. Like this. Do you follow? Any questions so far? Okay. So we have to extend this because the next positive edge is the next positive. This is the next significant event because we are told that it is a positive edge-driven JK flip-flop. So when it's 0, 0, okay, no change, and it's usually and then it's 0 at the start, so Q will remain 0 until the first edge, no? And then we have 1, 1. Okay, so this is 0, 0, 0. Okay, at this point this will be 1, 1. Okay, do you follow? So from 0 this will become 1. Okay, let's change to the okay, and we'll copy this. Okay. Okay. And then we look at the next positive edge, rising edge, right? Do you follow? So nothing will happen in between because this is a falling edge. The next thing that will happen is on the rising edge. So on this rising edge, we have here this as 1, 1. So what will happen to this? This will shift to 0. Okay. Let's move this to the left. Okay. This will shift to 0. So we'll just copy this. Then we'll copy an edge. Doesn't have to be perfect, okay? Hirap ito ma-perfect. Okay. Why is it? Because 1, 1 for a JK flip-flop is a flip, right? It's a flip. So it will remain 0 until the next rising edge here. Okay, so you just have to copy this. Mahirap, this is difficult only at the start, no? Do you follow? Do you follow? Next time, I'm going to do this by hand, okay? Para mas madali. I don't have a third camera, second camera pa kasi. No, it's not ready. So look at this, no? What number is this? This is 0. This is 1. Sorry, this is 1 here. This is 1. Okay. Let me set. J is a set, SR. K is a reset. Do you follow? J is a set, which means it will set to 1. K is a reset, which is 0. So therefore, okay, this will be a 0. Okay, this will be a 0. Any questions? Why is this a 0? Because it's a reset, no? Do you follow? SR man, RS, no? SR, J is connected to S, K is connected to R. So this is a reset, so this will become 0 at this point. So we'll just extend this until the next. Okay. We'll extend this up to there. Okay. Any questions so far? Now, in the actual test, no? Ano ba to? what will happen? What will we do? I'll just give you a few problems. No, anyway, you'll have 3 days. Okay, 3 days. You'll have 3 days to do the actual test. So I think you can still do this in Excel. The only you can just have mahirap lang siya sa simula, but if you already have a figure, you can already just copy and paste. Okay. They follow. So this is the next edge, no? This is the next rising edge. At this point, this is a 1 and this is a 0. Okay. What will happen? This is a set, so therefore this will shift to 1. We'll have to copy this. Okay. And then this will remain the same until the next rising edge. Okay, we follow until here. No? So this now becomes a 1. We follow? We follow? On the next rising edge, what happens to this? This is a 0. This is also a 0. So therefore, there will be no change. Ano lang yan, no? Okay. Okay. Any questions so far? Okay. CE means clear. Okay. It's a D flip-flop with a clear, no? Any questions so far? No? That's 11-7. Is there a figure that is given? 11-27. Okay. DCE flip-flop in 11-27. Let's look at 11-27. Ito, no? Okay. There's a clock. So this is enable. Okay. CE means clear. It must be this, no? Which ano ba? In the 11-8. DC flip-flop of 11-27C. Ito, no? Okay. Okay. Ang hirap dito ang ano, no? Ito na lang, we'll use this, no? We are using a negative clock. Itong B na lang because actually it's just the same as this. No? DCE. CE means clear. Okay? Which means if it's a clear, D will be 0. Do you follow? D will be 0. It's the same thing, no? Pareho lang ito sila because it's undead. Now, if it's clear, D will be 0. Okay. Clear means 0. Set means, preset means 1. Okay? Do you follow? No? 11-8. So we can just copy this. Problema, hindi na magkasya, no? You have that. So we'll just have a D. Okay, and we'll have a CE. Okay. When clear is high, no? It's enabled. Clear enable, no? When clear is low, it's not it's disabled. If follow? Now we will only look at the clear enable. Okay. during the high, it's a negative clock, right? So negative clock, 11-27. So negative clock, no? So we look at the falling edges. Okay? Do you follow? So D. So paano nangyari yung D? So D will be here. E is initially high. To this point, let me just erase everything. Sorry, na-erase pati yung linya, no? But it's okay, no? You can just easily copy it. Ano? Kamali ako ng click. So I will erase. No? Okay, what happened to our D? So our D is slightly in the middle. Have it here. Okay, and we'll put this below. Okay, we extend up to 1, 2, 3, up to the third. Okay. Up to the third. 1, 2, 3. 1, 2, 3. And then it goes back to the fourth. Tama na ito. We'll just put this below. Okay. Now, is this correct? It's down. Yeah, we're looking at this and then, yeah. On the beginning of the third, no. Dapat wala dito, no? Because it extends. Yan. Okay. Tama ba? So dito siya sa last. This will be our last, ano? Wala na ito. Because we only have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we will not have this anymore. We'll erase the no borders. Okay. Diyan lang tayo. Okay. Okay. What will be our CE? Our CE is high at the start. So we'll have to remove this. Is high until at the middle. Remember, we have a negative clock, no? We'll just change this. Negative clock. We have to identify that it's negative there. No? We'll put the C is high at this point until the middle. No? Until the middle. There. No? And then it's low. We have to move this here. And then when is it high again? Here. The middle. So we have to copy this. Here. And then the thing dito, it is going to be low again. Sorry. Just have to extend. Okay. then we'll have a low again. Okay. And then we'll have another low until the you can use bitmap now if you like. No, here this is 1, 2, 3, 4 in the middle of fourth. 1, 2, 3, 4. So we'll extend it here in the middle of the fourth and the fifth. Dito sa fifth. Hindi, no? Kasi mali. This is in between the two. 1, 2, 3, 4. 1, 2, 3, 4. Dito dapat sa 4. Nasa 3 siya. So sa 4 and goes down here na. Ito siya bababa. Okay. Then we'll copy this. And remains to be that way. Is it correct ba? Yeah, that's correct. No? Okay. Okay. So let's erase this. Ilang tayo mag-erase ng ano? First, no? Okay? Okay. So anyway, we'll be looking at the falling edges. Okay. So initially Q is low. So nothing will happen when until the clock is until the clock falls. So this we will look at here up to this point. Okay. Do you follow? Any questions so far? No. So dito tayo because we have a negative clock. So therefore, what will happen here? Clear enable is low. So therefore, there will be no clear. And D is low. So therefore, it will still be low. And we will be looking at the next part. Dito, we will just extend up to the next falling edge. Do you follow? Okay. So anyway, this is what's up to this point. This is a negative clock. So what is this? This is 0. And D here is also a 0. So therefore, this will be a 0. Remove it here. Do you follow? Okay, because Q receives D. Not unless we have a clear enable. Okay? Do you follow? What will happen up to this point? This. Okay. Clear enable. The clear enable will supersede D. Okay, so it's a clear, so therefore it will be this point here is a 0. No? Let's move it to the left. And this point here is a 1. Okay. So what will what will be used, clear or zero or D? It will be clear because clear is the priority because it's ended with D. So anything ended with clear enable, clear will zero out. So therefore, this will be a zero. It's not a preset, no? That's the difference between a clear and preset. A clear will zero out, and a preset will set it to 1. Okay. So we'll extend this until the next falling edge. Okay. Do you follow? Okay. So at this point, at the falling edge, D is 1, clear enable is 0. Okay. Clear enable is 0. So what will happen to Q? Q receives D, right? So therefore, we will set this high. Okay. Then we'll copy this. Tingnan natin yan ilalagay, no? Sayang naman yan, yan, no? Okay. And then the next, until the next falling edge. Okay, hanggang dito. The next falling edge is the significant edge. Okay. In this falling edge, no, what is D? D is 1. Okay. And clear enable is 0. Okay. Sorry, this one. Do you follow? Now, what will be clear enable will make it 0. But when D is equal to 1, it will make Q as 1. But with which one will take effect? The clear or the D? The clear, because it's undead, no? So therefore, this will become a 0. Okay. So we'll just copy this here, no? And then the next falling edge will be here. Do you follow? So both D 0 and clear enable is 0 again, no? Do you follow? So therefore, we'll just extend this to be 0. We'll remove this. Okay. Bayaan mo na yung ibang edges, okay? Any questions so far? No? So we'll go to 11-9. Eleven na lang, no? Kasi useless itong 11-9, no? We have done this again. So we'll go to 11-11, okay? Change this. Useless yung 11 ano? 11-8 and 11-11. Okay. Okay, useless yung 11 ano? 11-9. Let's see. So 11-11, this is it. Now complete the timing diagram for the SR flip-flop. Wala tayong Q. Okay? Do you follow? Fortunately, no, there's no race condition because there's no instance where S and R are both high at the same time. Okay? 11-11. So if I will upload this, no? I will upload this to our website. Anyway, let's look at 11-11. So it's a little bit strange, no? Yeah. We'll just copy the clock first. So we can have that. It's not clock, no? What's this? This is this is S. So mataas siya dito, we'll have this. We'll clear the, no? Clear the border. Instead, we'll have a bottom border. Thick bottom border. Then, how do we draw this? Draw na lang natin as a line, okay? Because there's no way we can draw this as a, okay? So we'll copy it from our, from our previous, this. Okay na itong hindi na-copy yung ano, no? Anyway, we'll just, yeah. Straight now. Okay. Like that. Then we'll have a long line. Copy this. Sure. Then we'll have 1.5. 1.5 square. Copy this. Sorry, no. Tapos patayin nito, no? I'll upload this. problema pag then we'll have 1 up. Then we'll have 1/2. Then we'll have this. Okay, just copy the rest, no? Then move it here. It's our S, or R. There's a way to do this quickly, no? We'll just copy this. Okay. Tama ba? Then this. Then the R is somewhere in the middle. Let's say. This. Okay. Then this should be extended. Bali ng slight imperfection is okay. And then we'll just copy this. Because we'll put it here. Extend this. You follow? Pwede na yan. What will be our Q? Our Q starts with high. Nandito sa taas, no? First, we look at set. The first that comes is set. Okay? So it will be set up to this point. This is 1. This is 0. Okay? For 1, 0, what will be the effect? It will be a set. This is a 1. Okay, so this will be a set. No? There is no clock, no? So therefore, it will be set. Pagdating na nag-high, it will be set. It will continue to be set because it's still set at this point. Do you follow? Okay. At this point, no, we'll have 0 and 0, right? We'll put this left. Okay. We'll also put this left. So pwede na yan dyan, no? So for a 0, 0, I will put this at the center. Continue at center. No. Tama ito. Ito ang center, no? Okay. Sorry, this is annoying me. Kumabas na. I made a mistake. Clicking. So anyway. So the problem is this. We have a 0 and this is a 1. Right? Up to this point, this is still a 0. So there will be no change. No? 0, 0 means no change. Do you follow? Okay. Now this is a reset. Okay. So this will still be a 0 to this point. Okay. Now this here is a 0, 0. Okay. A reset means a 0, right? So 0 ito. So this is 0, 0. So this will still continue to be 0 up to this point. I'm sorry. No, I'm sorry. Mali 1 pala yung tiningnan ko, no? It's initially 1. Okay. So up to this point, it's a reset. Okay. So a reset will become a 0. Not this, will copy this. Okay. And it will become a 0 until it's a reset. While it's a reset. Okay. Okay. Any questions? So reset, it will continue to be a 0 because it's a reset. Now at this point, it's a 0, 0. So there will be no change. Right? Until here. Okay. At this point, we have a set. So we need to copy this because a set will change this back to 1. Okay. So it will continue to be a set up to this point. Okay. Up to this point because it's still a set. Okay. And here it will be a 0, 0. Right? It's a 0, 0. So a 0, 0 means no change. But here it's a 1, 1. It's a 1, 0. Okay. So it's a 1, 0. So no change ito, no? But here it's again a set. So we'll continue to go back here, continue here. But now it's a 0, 0. So this is a no change. Until here we have a reset. Okay. Ang hirap itong online, no? Okay. So we have a reset. So this will become a 0. This is a, no, this is a 1. This is a 0. We'll set it to the left. This one will set also to the left. So this will become a reset. And pagdating dito is a no change, no? So no change. So it will continue to be a 0. Okay, you will be given, that's why you will be given 3 days to do the test. Okay. Any questions so far? So we have 5 minutes more, so I will not introduce a new topic anymore, no? So this is 11-7, 11-8, and 11-11. Okay. Any questions so far? I'll upload this, no? I'll upload this. Set 7, 8, and 11. Okay. Do you follow? Okay. Any questions so far? So these are timing diagrams, no? And then we will have problems with propagation. So meron na tayong D, we have JK, and we have SR. Okay. Do you follow? So I think this is a sufficient set of exercises because we have D, JK, and SR. So we'll have 2 meetings more, no? So we'll have 1 meeting for registers and we'll have meeting for Quine McCluskey and Petrix. So medyo masikip, no? Okay. Any questions? Okay. So I'll upload this and then you study this. Okay. You solve the other exercises. You just choose any, no? Okay. Now it's important if S and R you don't have a clock, no? But for D and JK, it's important to look at the figure whether it's a negative clock or it's a positive clock. Okay. Any questions so far? Okay, I'll upload this now and you study the solution. Thank you very much. Now, next time we'll be meeting again. Okay, I hope you'll be able to finish the whole thing. Okay, thanks everyone for coming. Okay, 11, 12:40, 12, it's 12:35. We're supposed to end at 12:40. So we can solve any more exercise, okay? I'll upload this, okay?
Yes, sir.
Yes, sir.
Very much now.
Thank you, sir.
Yes, sir.
Bye,
Yes,
sir.
sir. Bye, sir.